Hello students, and welcome again to lesson 3 in the probability unit, and this lesson is going to be about tree diagrams. Just as before, a few vocabulary terms you'll need to know. Tree diagram is one, and tree diagrams are useful for describing relatively small sample spaces and computing probabilities, as well as for visually why the number of outcomes can be extremely large. So it is a visual aid basically to check out the outcomes of possible scenarios. An event is another term you'll need to know, and an event is any collection of outcomes of an experiment. Compound events are any events which consist of more than one outcome. And finally, a two-way table. This is another visual tool that is useful for examining relationships between categorical variables. So if we had, it's kind of like a tree diagram, it's just a table way of looking at the same data. If you need to stop or pause the video in order to finish jotting down the definitions in your guided notes, feel free to do so. Okay, the first thing we're going to look at is how to actually make a tree diagram, and then we will look at how to use it to find probabilities. So making a tree diagram, example 1. And in this example, we are in a real-world situation where you will be ordering a fruit smoothie. You have your choice of small, medium, or large smoothie, and you can include one of the following fruits, either strawberries, bananas, or oranges. And so we want to know how many different choices of smoothie do we have. So if we start our tree diagram, and this is one that runs horizontally, they can also run vertically, but we start our tree diagram with the different sizes of smoothie we can get. We can get a small, a medium, or a large. From there, we would then branch again into adding the 3 different types of fruit. So to a small, we could either add strawberry, banana, or orange. We could do the same thing to a medium smoothie, strawberry, banana, or orange. And then also to a large smoothie. So, oops, let me go back one, sorry. To a large smoothie, strawberry, banana, or orange. So with those, then we can combine the different branches of our tree to get a small strawberry, small banana, small orange, medium strawberry, medium banana, medium orange, and large strawberry, large banana, and large orange. So to answer the question of how many different choices we have, there are actually 9 different choices of smoothie. Again, comparing the size and the different fruits that we can get. So as you can see, a tree diagram is just a visual way of representing the possible outcomes. Alright, here's another example of making a tree diagram, and this one is a vertical tree diagram. And the situation we'll look at now is that we're going to be attending 2 sessions at a science camp. At each session, you will be assigned to one of the following groups. We'll either be in the red group, the green group, the blue group, or the yellow group. We will not be assigned to the same group for both sessions. So, how many possible outcomes do we have? So, for example, if session 1 were red, session 2 we would not be red. Alright, so here's going to be our tree diagram. First thing I'm going to do is for session 1, my possible choices are 4. I could either be in the red group, the green group, the blue group, or the yellow group. And then for session 2, if I was in the red group for session 1, then the only choices I could be is in the green, blue, or yellow group. Alright, the fact that I can't be back into the same color. And if you look at the green tab here, if my first group is green, then my second session I would either be red, blue, or yellow. And so on and so forth. We'd work down that. So, and again, if my first session I was blue, then I could either be red, green, or yellow. And finally, if my first session was yellow, then I would either be red, green, or blue. So to look at those questions and to look at those possible outcomes, you would notice that there are 12 possible group assignments. I could be red, green, okay, first session, second session, red, green. I could be red, blue. I could be red, yellow. If I'm going here, I could be red, green, red, blue, red, yellow. Or if I'm looking at the third area, I could be blue, red, blue, green, blue, yellow. Or again, if I'm over by the yellow, oops. Sorry, y'all, let me go back here. Okay, if I'm over at the blue, I could be blue, red, blue, green, blue, yellow, and then finally yellow, red, yellow, green, yellow, blue. So my possible outcomes are 12 different groupings that are possible. So again, a tree diagram can visually help me to match those and line those up. Okay, here's a slide that says your turn at the top. So in this case, I would like for you to try this one on your own. And again, we will be going over this in class tomorrow. So take a minute to pause the video and complete your question, and then we'll go over your answer tomorrow. Okay, now that we've had a little bit of practice making a tree diagram, now we want to see, okay, using a tree diagram. So in this case, to find probabilities, we would use a tree diagram. So let me get my pen going here. All right, and in this case it says to find the probability of getting at least 2 heads on tossing a coin 3 times. Make a tree diagram to find the outcomes. All right, so we've gone ahead and did that. In my first toss, my options are either heads or tails. All right, in my second toss, again, heads or tails. So if in my first toss I tossed heads, then my second toss, again, I would have heads or tails. If my first toss was tails, then I'm going to represent the 2 options from here on this side, which again would be heads or tails. And then finally, in my third toss, if I got a heads for my second toss, then again, heads or tails. If I got a tails for my second toss, heads or tails. If I got a heads for my second toss from my first toss being a tails, then heads or tails. And if I got a tails on my second toss after my first toss was a heads, I'd have heads or tails. I know this can kind of be confusing to explain it, but I think visually you probably understand where we're getting at. Again, the question up here said, find the probability of getting at least 2 heads when tossing a coin 3 times. So as I look down my tree diagram, I'm going to make some letters that would represent the different outcomes. Well, I could have heads, 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 so therefore I have 3 H's. I could have heads, heads, tails, so 2 H's and a T. I could have heads, tails, heads, 2 H's and a T again. Or I could have a heads, tails, tails. All right, so those are the one possible scenario. The other possible scenario would be on this side of the diagram. All right, if I started with a tails, I could go tails, heads, heads. I could go tails, heads, tails. I could go tails, tails, heads, or I could go tails, tails, tails. Okay, so these are my possible scenarios. Because it wants me to find the probability of tossing 2 heads, then I would circle all of the outcomes that had 2 H's in them. And so these were the 4 that had 2 H's. So I have 4 possible outcomes out of a total of 8. Alright, so again, I could show that as favorable outcomes or successes over, in this case it would be successes over trials, or 1/2. So my probability of getting 2 heads when I toss a coin 3 times would be 1/2, 50%, or 0.5. Alright, here's another example of how we will use a tree diagram. In this case, we're going to talk about outfits and choosing an outfit. You can choose from a t-shirt. As far as a top, you could choose from a t-shirt, a button-down shirt, or a sweater. And as far as pants, we have the option of having jeans, dress pants, or khakis. So those are my 3 choices. And you can see the diagram down here, and then the different letters that would represent each of the choice options. So the first part of the question says to make a tree diagram to determine the number of possible outfits you could make. So go ahead and pause the movie and take a minute just to do that diagram before you move on. Okay, now you may not have the drawings like I do, the sketches, but you may have the letters that would represent each of the outcomes, and hopefully your tree diagram would look somewhat like mine. And so let's go ahead and, now we have our tree diagram, let's go ahead and look at the questions. Let's find the probability that the outfit you choose will have khaki pants. Alright, well, so we need to look at the different outcomes in the tree diagram. Well, we could wear a t-shirt with khakis, we could wear the button-down with khakis, or we could wear the sweater with khakis. So I have 1, 2, 3 favorable outcomes in which I would have khaki pants. And that would be over the total number of outcomes. Well, I could have 1, 2, 3, 4, 5, 6, 7, 8, 9 different outfits that I could wear with those pieces of clothing. So 3/9, which I would of course want to reduce to 1/3. So my probability of choosing an outfit that has khaki pants would be 1/3. Right now, let's look at the second question. Find the probability that the outfit you choose will be the sweater and jeans. Alright, well, I'm going to change my pen color here so that we can. And since I'm sweater and jeans, I'm looking over here. So sweater and jeans, well, there's only going to be one option for me to choose sweater and jeans. Only one choice. So my favorable outcomes would be 1. My total outcomes would still be 9. I haven't changed any of that. So 1/9 would be the probability that I would choose an outfit that has a sweater and jeans. Alright, and finally we're going to have you get a chance here. So you making and using a tree diagram, your turn. In this case, you're going to talk about making choosing different types of sandwiches and different types of breads. So read this question, go ahead and complete it on your own, and we will go over the answer tomorrow in class. Good luck. This is the end of lesson 3, and we will answer any questions you have tomorrow. All right, good luck. Thank you.